What do you got?
So I think the reason I don't get it because I only have one formula written, which is the friction formula. But it says if a 3K block rests on a rough horizontal table and experiences a 2 in force of static friction, then what is the coefficient of static friction between the block and the table? And it says use G equals 9.81.
Okay. So I'm doing this one with you all. If you're at this one now, we're working it. If you're not at it yet, should you maybe put it in your notebook and work through with us, and then you'll know the answer and you'll know how to do it, right? Here we go. We are given that there is a 3-kilogram block. We're told that it's sitting on a table. We're told that the static friction is equal to 2N. By the way, that's going to be your force of friction. They give it to you, 2 newtons. This goofy looking U with a line on the front is the coefficient of friction. That's how well these are going to slide past each other, or not well, they'll slide past each other, right? That's what's holding them from sliding. You'd need 2 newtons of force to overcome that. Does that make sense? But what is the coefficient? And what?
I already did the question.
Great. Do you need one of these two then? Yes, you do. Yes, you do.
I don't know if I did.
Now, if you want to follow along with these, because you know you got it wrong, or you don't know why how you got it right, okay? But otherwise, you're watching the skydiving video and answering those questions. All right. So, what do? We want to use a formula that will give us the coefficient of friction. This formula has a coefficient of friction, and it has the friction force, which we're given. What goes here? What are we multiplying the coefficient of friction by? With a what? Newtons of what?
G.
This is not a weight, is it?
Force.
This is a mass.
Mass, yeah.
Weight is a force. We need the normal force. Okay? If you look right here, what's that say? Fn.
Normal force.
Normal force. So let me put that right here, because I got derailed for a second. Because she threw in the use 9.81. Of course we use 9.81. All right, so this is the formula we're going to use. What do we have that we can put into that formula? We can put the 2 newtons right here. And somebody said we could put the mass in there that doesn't ask for the mass anywhere. This formula does not ask for mass.
Oh, I thought that was the M thing.
This?
Yeah.
Nope, it's the goofy U coefficient of friction thing. Okay? So that's it? We only have one of the 3 variables. We can't answer the question, can we? Or would I be able to find the normal force? How do I find the normal force then?
3 times 9.81.
Oh, because you remembered force is equal to mass times acceleration. And if we're given acceleration is 9.81, which you said we were, and we know the mass is 3, we just multiply those and we get what? 29.43 newtons. Well, now what do? Do we have 2 of the 3 variables? What do we do to the variable that we're missing? Get rid of it? How do we get rid of it? What do you mean get rid of it?
You get it alone.
You get it alone. If you want to beat up on somebody, it's easier if they're not by their buddies, right? We want to beat up. We want to solve this variable. We want to beat up on it, so we're going to get it all by itself. We're going to isolate it, right? Is that the math term? Isolate the variable. Okay, so how do we get this by itself over here? We got its buddy over here. We got to do what to it? Divide it out. 29.43 newtons, and then that just turns into a 1. Well, whatever this coefficient of friction is times 1 is just the coefficient of friction, right? Which is what we're looking for. So we get rid of it over here. But can we just do that and say, well, 2 newtons is The coefficient of friction? No, we have to do what? If we did it to one side, we got to do it to the other. Good. So what is 2 divided by 29.43? By the way, the newtons would divide out too. So you wouldn't have those for your unit anymore.
0.067.
Could we round to 0.7 maybe?
Yep.
Let's try that.
6.8.
So 0.07 is our coefficient of friction. That's the hardest one today. You guys started with the hardest one. That one had me scratching my head for, let's just call it a couple minutes in first period. I totally wasn't sweating bullets.
It wants us to run the nearest 100.
You what?
Round to the nearest 100.
Oh, it told you to. Okay, so it would be 0.67. Did it take it at 0.7?
No.
It wouldn't?
Well, I put 0.7 and it's
It's 0.067. It's going to be 0.7.
Oh, 0.07.
He put on the board.
So 2 divided by 29.43 is 0.0. I probably just misheard you. 0.067. So I rounded to the hundredth would be 0.07. Good. Let me know if you get another one. Oh, you got one?
Yeah. If a 100-Newton block is resting on a steel table with a coefficient of static friction, the weird thing, S, equals to 0.68, then
What was the coefficient of friction?
the coefficient of static friction is the, you know that weird looking thing?
Yeah.
Is 0.68. Then what minimum force is required to move the block?
So we're looking for friction force, right? What force to overcome that? Is this all we're given?
Yes.
And we're looking for the force of friction. All right, so I'm going to tell you what formula to use. It's right here. Okay, use that one. Force of friction is equal to the coefficient of friction times the normal force. Go ahead and plug it in and solve. Yep, I think you can get that one. That's not an M. Somebody earlier said, oh, it's an M, so it's mass. No, I'm sorry. It's a goofy looking U, kind of symbol for coefficient. Probably has a fancy Greek name. So what plugs in for force of friction? Are we given the force of friction? No, it just comes down. That's what we're looking for. What do we have for our coefficient? Just plug it in. Plug it in, plug it in. And what do we have for our normal force is 100? Well, that's an easy one. Do the math. Because the variable you're looking for is already isolated. It's already by itself. You can beat on it all day long. You can't do anything. It won't even fight back. It'll be like, hey, just solve for me, man. Just take the answer. It's not worth fighting over.
Would you put the 0.68 over to 100? How'd you do that?
So because they're right up against each other, the way I did it here, the way they did it, they put them both in parentheses with nothing in between. So that means what?
They're multiplying.
Yep, you're multiplying. if you get another one. Barrett, did you have another one, or is that the one you have?
Yeah, 0.6800.
No, I'm saying, was there another? You had your hand up too. She had her hand up. I didn't know who.
Oh, yeah, I have another one.
You got another one. Can I erase this? Wait. Oh, wait. I can wait. Are we good now? Almost. All right. Hurry up! All right, good. Awesome. All right, Beck, what do you got?
If a 3,000 kilogram car is pulled with a force of 11,000 newtons to the right, causing it to accelerate at 3 meters per second squared, then what is the force of friction acting on the car?
Hold on, I'm too busy drawing a car. And then it was pulled by 11,000 Newton force.
Uh-huh.
And we're looking for the friction, right?
Mm-hmm.
What kind of friction would that be if it's on wheels and it's? Did you guys not do the reading? I click on the thing and stuff. I did read it to you. So do you remember the 4 types of friction? There's static friction, sliding friction, rolling friction, and fluid friction. Those are the 4 types of friction we talked about, or I read. What kind of friction would this be? Rolling friction, because it's on wheels, and as long as they're not stuck, right? If it's been sitting a long time and like the pads and everything's just rusted together, the brakes are seized, or the tire's so flat on the bottom you just pull it and it just drags, right? Then it'd be sliding friction. But it's rolling friction as long as everything's working order. What? Yeah, take a pass. So, what do we do? Does anybody know? Maybe the people that said they did it like yesterday, do they know what to do? We've got an 11,000 Newton force pulling on a 3,000 kilogram vehicle, and that causes what acceleration? I think we're missing that piece.
3 meters per second squared.
3 meters per second squared is the acceleration caused by pulling with that force on that mass vehicle. Okay, good. So that's our setup. Anybody have a clue what to do? By the way, it's not that. Well, we're not given the coefficient. And to use that formula, we'd need to have the weight, right, and the coefficient. But we don't really have that because our acceleration isn't down due to gravity. It's motion to the right. So what I do, and what I did first period, I was so proud of myself because math is not always easy for me, right? I just went crying home to mama. When I do that with physics, I usually just say, well, can I use force equals mass times acceleration? That's like my go-to formula. If I can't think, I don't know what to do. Can I use that? And sometimes the answer is no, and then I'm just lost. But if I can use this, a lot of physics is force equals mass times acceleration, or some variant of it, right? So what is the force we're given? What's the force we're given? Don't jump to the answer that you guessed at. We're given 11,000 newtons is equal to mass, we're also given, which is 3,000 kilograms, times, we're given the acceleration, which is 3 meters per second squared. Okay, we're given everything. But I want you to look at that equation and tell me, is it an equation? Why is it an equation? Does 3,000 times 3 equal 11,000? What does it equal? 9,000. Wait a minute, they're pulling a fast one on us. Their math's wrong. Is it? What are we looking for? Which is something that would make it take more than it would otherwise to pull on it, right? So we're saying, listen, it should only take 9,000 newtons of force to pull 3,000 kilograms at an acceleration rate of 3 meters per second squared, but that would be assuming what? No friction. But there is friction. And friction acts in what direction to the motion? The opposite. So we've got 11,000 newtons of force pulling it this way. We have how many newtons of force pulling it the other way?
2,000.
Don't just throw out guesses. Who guessed 3,000?
I just repeated what you said.
3,000 is our mass of the vehicle. Oh, you just repeated? Okay. 11 minus 9 is 2, right? So we got 2,000 newtons of force pulling in the opposite direction. That's it. That's your answer.
That's crazy.
You're pulling, if there was no friction, pulling with 9,000 newtons would get it moving at that rate of speed, or that rate of acceleration. But there is friction, 2,000 pulling in the opposite direction. So you need to have 2,000 extra newtons of force to get it going at that rate of acceleration. Yes? Yes. So you're looking for a difference in how much force was actually applied versus how much would be applied without friction. Does that make sense? So we found that difference here, and that was the friction force. Yes?
Did you say for the difference you did 11,000 minus 9,000?
11,000 minus 9,000 equals 2,000.
So how did you get the 9,000?
The mass times acceleration. Force
Oh,
equals
yeah.
mass times acceleration. Because we did that, and we're like, wait a minute, that's not what they had. Oh, that makes sense, because the friction is going to be working in the opposite direction. Does everybody get that? Everybody understand what we did here before we move to the next question? Do you have our next question? All right, let me erase this.
Can I ask you a question?
How about this? Yeah?
No.
So like, for force equals mass times acceleration, do we use that on every question?
No.
Does
Uh-uh.
it give the,
But I keep it in mind because it might help me. All right? Because our little equations up here, I didn't see an example. Maybe in the other questions you worked. This is something you've already learned, isn't it? So they shouldn't have to remind you of this. I guess that's the point. They're expecting you to already know this. And you do, right? You know that force equals mass times acceleration. And our problem gave us mass and acceleration, and it gave us a force. So they're expecting you to be like, wait a minute, that times that doesn't equal that. We're looking, oh, yeah. That's what we're looking for. We're looking for the difference between what they gave us and what it would take without friction. And the difference is the friction. Yeah. You have one. She had one first. Can I erase this? Can I erase this? What do you need?
I know I have one.
Okay, we're going to start with hers, and that might be the same as one of yours. So here we go. Get some space. What's yours?
If a 40 Newton block is resting on a rough horizontal table with a coefficient of a static friction, then the U thing in the S equals 0.60, then what is the force of static friction acting on the block?
So we're given the normal force, or the opposite of normal force, right, which is the weight. So the weight, the opposite is the normal force, so it's still 40 newtons. Just adding, it's just applied in the opposite direction, right? Because the table is resisting the force of gravity on the block. So normal force is going to be 40. We're looking for this. So we're just using that formula again right there. So just set that up. We're looking for that. The equation tells us to put in the coefficient times the normal force. So we're given everything we need. So just plug it in the formula and do what it says. Give everybody a chance. didn't even say the weird U. Isn't that what I called it? The weird U? What's it called? Mu? Mu? Is it called mu or mu? The Greek letter is called mu. All right. So your peer tutor looked up the goofy looking U thing, and it's called a MU, mu, or mu. The Greek letter. Huh?
I think it says that in the text.
Oh, does it too? Oh, there you go.
Would the weight be the Newton?
Would what?
What would the weight be then?
Weight is a force. Weight is a force, so it's in newtons.
What if you already found it?
You're looking for the force of friction. You're given the normal force, because isn't that the equal opposite of the weight of the block?
Yeah, I think.
Remember, the block is pushing down with 40 newtons because that's its weight. The table pushes back to hold it there. And that's the normal force. The pushback is the normal force.
This one's kind of different. It says if a 3 kilogram block rests on a rough horizontal table and experiences a 2 years force.
We did that one already.
We did?
Didn't we do that? Wasn't it the first one we did? Or was that a different class?
Yeah, it was the first one we did.
It's the first one we did. Pay attention. What?
I was about to.
Yeah, take the pass. So we just 0.6 times 40, and what do we get?
24.
Is it 24?
It's 24.
24 what?
There's
Good job, dude. Can you use the bathroom after Nelson?
You didn't raise your hand. She goes next, and you go after her. Okay. Do you have another one? Wait. Did you have a different one?
No, I'm the same one.
You have the same one? Oh, perfect. Did somebody back there have another one? And
Oh, yeah, I have one.
a different one than the three?
I think so.
Okay.
If a 10.4 gram block is on a rough horizontal table with a coefficient of friction with a weird U equals 0.15, then what is the resulting force of friction on the block? Use G equals 9.
Okay. This is just like, very similar, isn't it, to the first one we did? Very similar. It's not exactly the same, I don't think. So, we're looking for the friction force again. So we'd be using that formula again. Friction force is equal to the coefficient of friction times the normal force, right? So what do we have? What are we
Do
given?
you have the weight?
We do not have the weight.
It's 10.4.
That is not the weight. That's the mass.
we don't have to wait.
We don't have the weight. Can we find the mass? Or excuse me, can we find the weight?
Oh, yeah.
Yeah. How do we find the weight? What did it say to use in the note?
It says G equals 9.
And G is acceleration due to, what's G? Gravity on Earth. And it tells you it's 9.81 meters per second squared, right? So what formula would I need to use for that, do you think? Right? So we can find the weight. The weight is F. So how do I do that? Right? They gave us the 9.81. And they also gave us the mass of the block. So we just multiply that to get our weight in newtons, which is equivalent to our normal force. Right? And then we can plug it into our formula. But we're given something right off the bat, right? Aren't we given the coefficient of friction? So we can put that in. All right, so what's 10.4 times 9.81?
102.0.
That?
Yep.
Okay. All right, so that's our normal force. We just plug that in right here. And then all we have to do is multiply, right? To find our friction force. What's up, Alex?
I had a question.
You. On these or on your parachutists? Not the weight.
15.3.
What is it? 15.3?
Yeah, 15.3.
So if you multiply that, you end up with 15.3 what? Friction force would be in what? Newtons. You got one? Yeah, we got one. All right, I just finished writing though. Give you a second. Does anybody probably need more time to write, or are we good? Can I erase that yet?
Yes.
Yes? What?
I know that one is it.
Yeah. All right, here we go. I'm going to erase starting over here. All right, so, Greg, what do you got?
If it's a 20 block, it's a force of anchor in 8.6 below, and from the surface of the table, where is this?
So we're looking for the coefficient between the block and the table, right? And what was the mass of the block? 20? Okay, we got 20 Newton. That's not, wait, mass? Or was it?
No, not mass.
Hold up. The block, is it 20 Newtons or 20 kilograms? Newtons. So we have the weight of the block. Good. And we're looking for this. What was the friction force? 8.0 newtons, right? And what's it at? We need the coefficient of friction. What's up?
Wait. I got a question after this question.
Okay, cool. So is this setup look right? The block weighs 20 newtons. The friction force is 8 newtons, and we're looking for that. Okay, so can I erase the rest of this now? We're going to be using that same formula though, right? Should be the same formula. So we have our force of friction equal to mu times normal force. So we just plug in what we're given. The normal force is equal and opposite to it's the same as the weight of the block because it's just pushing back with the same force. So we got 20 newtons times mu, which is kind of fun to say, is going to be equal to, we're given 8.0 newtons. So what do I have to do to the variable that has a friend with them? Which does what for the friend with the variable that we're trying to solve for? It separates them, right? It separates them. So I divide both sides by 20 newtons. So this divides out, becomes a 1. Whatever the coefficient of friction is, times 1 is the coefficient of friction. And then 8 divided by 20 is 0.4. Is it 0.4 newtons? Oh, wait, is it newtons? No, look, the newtons divide out. So it's just 0.4 is equal to mu. Is that right? Swope's nodding. She's my fact checker. Are we good?
Yeah, I did
Oh.
like 17.
You need what? You did 17 of those?
Like, almost.
Okay.
I got a question.
What's your question, Fowler?
Alright, it says the force of. I just don't know how to set it up really.
Okay. Can I erase this?
Yeah.
Well, you weren't the one asking for. Who asked for this? Was it yours?
Yeah.
Are you done with it?
Yep.
Okay. Fowler, what do you got?
Force of 6 Newton pushes on a 2 kilogram block.
Hold up. Hold up. I got 6 newtons pushing on a how many kilogram block?
2.
2 kilogram block.
And it's accelerating at 3 meters per second.
Didn't we already do this one? Oh, we didn't do this one yet. I did it earlier in the day. Ooh, this one's fun. Fowler, this one's fun. I'm
I
glad
didn't
you.
know how to set it up.
I'm glad. Well, it's just like the car. It's like the 3,000 kilogram car. Okay, so what is it asking for? Force of friction. We are looking for the force of friction. I want you to tell yourself, if I can't figure out how to put it in that, because I don't have the information to put it in that formula, what formula do I cry home to whenever I'm like, I don't know.
F equals N times A.
Force equals mass times acceleration. Can I put in something for force that it gives me? 6, right? So 6 newtons is equal to what's mass? 2 kilograms. And what's acceleration? 3 meters per second squared. Okay, what's 2 times 3? 6. What's the difference between 6 and 6?
0.
What's that tell you? What does it tell you?
And it's 0.
This is 0. There's no friction. So this is like some kind of perfect situation here where
That's what I was thinking.
somehow you eliminated friction. What?
I have a problem.
Which, by the way, if you can figure out how to eliminate friction entirely, go to one of these major companies. Go to 3M or something. Go to Valvoline or one of these big companies. Like, hey, I've solved friction for you. What?
Is there an equation to solve the
Yeah, that one right there. So, okay, that's good. That's good. He says, is there an equation to solve for the coefficient of friction, for mu, as we're told it's called? Well, haven't we been using, let me erase this. The question is there an equation to just plug directly in? Correct me if I'm wrong. You're asking for a formula that will be mu equals something something, right?
Yeah.
What we've been doing is force of friction is equal to mu times normal force, right? What did we have to do? Didn't we have to divide out? We had to divide out the normal force. Doesn't that mean that mu is equal to final force divided by normal force? Doesn't it? You wanted a formula that would easily, directly, one step, solve for coefficient of friction. That's it. It's the same formula we've been using, just without the isolating the variable first. We're setting it up where the variable is isolated to begin with. Does that make sense? If you want to put that in your notes, that's the formula to find mu if you are given those two variables, force of friction and normal force. Yes? I got Wes first. What's up? Wait, not Wes. You're correct. I'm sorry. Go ahead.
Okay. Force of 6.0 1.0 kilogram block to withstand 4.0 masses squared to the right. And what is the force of friction acting on the block?
Okay. So we got a 1 kilogram block. You were going a little fast. I was trying to keep up. We're looking for force of friction. What was did it give you the acceleration?
The acceleration was 4.0 miles.
Meters per second squared. Okay. And was there any other information we were given?
It says the force is 6.0.
Newtons. 6.0 newtons of force applied on the block.
Yep.
Okay? All right, so it's another one similar to last. So which formula can we use for this? What is the formula that I cry home to?
Force equals mass times acceleration.
Now, let's take the information we're given, Dre. What are we given for force? 6.0 newtons is equal to, what were we given for mass? 1.0 kilograms. And what were we given for acceleration? Meters per second squared. Okay? All right, I'm going to ask you this question. Is 1 times 4 6? No. What is 1 times 4? 4. What is 6 minus 4? 2 newtons. No, 6 minus 4 is just 2. Okay? So think about it. 6 newtons are applied that way to get it accelerating to that rate of acceleration. But friction is pulling back with 2 newtons, isn't it? Force of friction is 2 newtons. Does that make sense? Yeah!
You want this? You want this?
Do you guys want the answers?
Yeah.
What? Just call them out.
Yeah. A, 1 is B. 2 is B. 3 is B. 4 is B. And 5 is D.
I got it all right. Well, me too.
Was that a fun video?
Yes. No.
What is he?
So, next door we go skydiving.
Yeah.